Hi, I'm Chris Cornelius, a professor here in the Chemical Engineering Department at the University of Nebraska-Lincoln. I'd like to take this moment to share with you a little bit about what it is to be a chemical engineer, and hopefully after that you too will be excited about the opportunities that exist in this discipline. As a little bit of background about myself, I was formerly a person when I finished my chemical engineering degree, worked for 3M, Dow Chemical, and because of my background, I worked on everything from the design of filtration media used for protective masks to design of new families of polymers with Dow Chemical. So these are opportunities that one could have as a chemical engineer. From that, I went on to get my PhD at Virginia Tech to be able to work in the area of polymer science and work on those type of things. And from that, I've worked on everything from designing polymers used for fuel cells to designing polymers used to desalinate water using electricity. So my hope is that if we provide this background for you, you'll see that the opportunities that exist for a chemical engineer is because of the curriculum that we have. So with that, let's go through a few things. So what is a chemical engineer? We're a little bit different from the other disciplines in the sense that we look at chemistry and we look at how we can transform materials and then use them in order to come up with solutions. So an example would be simply looking at raw materials, processing those raw materials and transforming them into products. An example would be looking at biofuels, taking those materials and then hopefully utilizing those materials to somehow benefit society as a whole. And I think that's a very unique talent and skill that we as chemical engineers possess, which is very interesting in my mind. So let's talk a little bit about how we're different in the sense of our technical challenges that we have. So as a chemical engineer, we may work with people that are in chemistry. Maybe they're designing a new type of material, a new pharmaceutical item, a new polymer. And what they do, we help implement ideas that are needed in order to scale them up from one size to a new size. So an example, we're working with chemistry and let's say we're designing a new type of family of pharmaceuticals. We would then look at the things that are fundamentally associated with making that new molecule, that new material, in order to make that material and design it so it can be scaled up. So in our discipline, we understand the basics of kinetics, thermodynamics, unit operations in order to build up a system to be able to then implement it on a large scale. And so we combine those basic areas of chemistry, biology, and physics in order to then look at how we might do something in a very safe way. Within our area, we also impact energy. So chemical engineers work on new types of fossil fuels, so petrochemical areas. We work on the design of new types of biofuels. We look at the design of new types of solar cells and how you might assemble them. We work on fuel cells. We look at energy storage as an example, looking at what it would take to build a material, separators, cathode, anode, the electrocatalyst behavior of material. And we look at those fundamentals, which is interesting within our discipline. Within the area of biomedical and biochemical engineering, we have computational people that may model the metabolic pathways that one would use to be able to understand how you would transform a molecule to make it useful, whether we're talking about looking at chemicals to design new types of fuels, to looking at how one would take molecules and remediate them in some way, and then in so take those things that we see within nature to be able to improve upon that from those things that we see. And as I said earlier, perhaps we may be even designing new types of drugs or manufacturing methods and delivery methods that one would utilize to be able to do these things. We also impact sustainability, looking at how chemical engineers will look at both the environmental, the social, and the economic impacts that one might see as a consequence of designing a new material or implementing a new technology. And we'll look at all these things and how they might benefit our environment, our economic impact. These are important areas. Chemical engineers look at things such as what do you do with waste instead of just landfilling it? What are the impacts of mining and harvesting minerals out of the earth? We might look at the water chemistry of that system to be able to try to improve upon it. Or if we're talking about petrochemical waste and the pollution that comes out of the air, we may do atmospheric chemistry to understand how to mitigate that or minimize that and its impact on our world as a whole. Or we might look at how we might take radioactive waste to be able to then take that in some way using inorganic chemistry or a new type of an approach, encapsulate that so that the half-life of these materials in the future do not impact our future. Or we might look at a very large scale reverse osmosis system and how we integrate that process in order to take water that is not able to be utilized and make it potable and usable for us as a whole. So when we look at the chemical engineering education, it is very foundational. And if we're looking at the overall structure of this, in all of our engineering programs, we have general education. That general education includes English, social studies, humanities, multicultural electives, and these are in place in order to make us a more well-rounded engineer. Where we start to differentiate ourselves probably from the other engineering disciplines is we start looking at chemistry, physics, and starting to emphasize heavily in these areas. Within that foundation, we have mathematics and biology that can be emphasized, that then are utilized to couple with perhaps business, ethics, and economic safety and environment. These things then couple to each other that we might utilize these things to impact the research that we do, or perhaps we go on to do graduate studies, maybe go to medical school, or become a professional consultant helping people understand the impacts of science and engineering. Or perhaps we take the other route in which our critical thinking has been developed in order to look at the impacts of sales, management, finance, regulatory things. Or a more traditional route in which we might be designing the operation of an overall chemical plant and communicating these ideas on a larger scale. So if you're interested in these things, or perhaps even more, what other scientific interests that you might have, you can also take within chemical engineering and couple that in order to have more than just a simple traditional chemical engineering route. For example, you can get minors in biology, chemistry, environmental engineering, material science areas. Perhaps you might want to emphasize math or cellular biology, or utilize chemical engineering as a way in which it will prepare you for medical school, or perhaps an MBA, or becoming a lawyer in the future. All these things are possible with a chemical engineering degree, as well as other engineering degree and disciplines as well. So one of the things that I would like you to consider if you're coming to the University of Nebraska is that there's always opportunities for you to do research within the laboratories with both the faculty as well as research professors here. In my opinion, undergraduate research is invaluable to your professional growth. It gives you an opportunity to work with others in the graduate discipline to be able to see how you critically think about an idea, implement an idea, and then turn it into an experiment and get results as an end goal to that, to hopefully publish or add knowledge to the scientific base. In addition to working and doing undergraduate research, it's a great way to earn additional credit, even monetary. There's opportunities to do summer research. There's opportunities to even do multi-year projects with professors that lead to publications, conference presentations, such as presentations at the American Chemical Society meeting or American Institute for Chemical Engineers. But the opportunities are quite broad, and if we look at this, here's one particular example of my own research where we're designing new types of inorganic metal alkoxides that was done by an undergraduate researcher, where we now have the ability and the understanding to take metals and their salts and combine them to create inorganic glasses made out of titanium, which is a very novel area. So where do chemical engineers work when they're done? Well, they work all over the spectrum, everything from traditional chemical design to creating new fuels, electronics, consumer products, materials, biochemistry, paper design, design and construction, research and testing, environmental engineering, business, and many others. And this just kind of gives you the spectrum of where a chemical engineer can work. So when we think about companies and starting salaries, the starting salary for a chemical engineer is over $60,000 a year. Placement rates are close to, if not equal to, 100%. The areas that you can work are incredibly broad, from 3M, Dow Chemical, Chevron, DuPont, British Petroleum, Battelle, Office of Naval Research, Fuel Cell Energy, BASF, and as I mentioned earlier, even going into law. So, chemical engineering provides you with a background that really equips you to be able to go to graduate school in multiple disciplines beyond just chemical engineering. It's a great opportunity. So in addition to becoming a chemical engineer, one of the things that we do, I think, is really highlighted quite well with the research and the discussion of Professor Smalley. Professor Smalley was a Nobel laureate who was able to really describe and design buckyballs. And perhaps you've heard those or not. But within his research, he mentioned that today there's the top 10 challenges that impact our world today. And those are energy, water, food, environment, poverty, and it goes on. Finally ending up with population. Earlier I mentioned where we impact, chemical engineers impact. It just so happens that we as chemical engineers impact these top three areas: energy, water, and food. Today, with a population over 7 billion people in the world, we can see that in the future, water usage, materials, food will be critical to our future. Chemical engineers play a dominant role in designing and understanding how we might address those things in the future. And I encourage you to really strongly consider becoming a chemical engineer as you come to the University of Nebraska-Lincoln. So with that, I'd like to leave you a contact information. My address and my phone number and email is here. And if you have any questions after viewing this video, I'm more than happy to visit with you on the phone, or perhaps you'd like to come see me as well. And with that, welcome to the University of Nebraska-Lincoln. Thank you.